Article 725.154c addresses support for bundled signal or data cables, stating that the support intervals shall not exceed 6 feet. This means that when multiple signal or data cables are bundled together, the group of cables needs to be supported at intervals no greater than 6 feet. Article 392.10b3 further clarifies cable bundling and support. It states that where bundling is permitted, cables shall be trained to minimize bending radius and shall be secured at intervals not to exceed 6 feet. Training cables to minimize bending radius is crucial for maintaining the integrity of the cable insulation and conductors, preventing damage that could lead to electrical faults or signal degradation. The 6-foot interval requirement applies to the bundled cables as a unit, not to each individual cable within the bundle. This means you do not need to individually support each cable every 6 feet if they are properly bundled. The key considerations are proper bundling techniques and adherence to the maximum support interval. When installing signal tray cables, there are several critical aspects to consider. Firstly, always consult the manufacturer's specifications for the specific type of cable being installed. Manufacturers often provide detailed guidelines on cable handling, bending radii, and support requirements. These guidelines can supersede or supplement the NEC requirements. Secondly, ensure that the cable tray system itself is properly installed and grounded. The cable tray must be capable of supporting the weight of the cables and any additional loads, such as ice or snow in certain environments. Grounding the cable tray is essential for safety and to minimize electromagnetic interference. Thirdly, pay close attention to the cable fill capacity of the cable tray. Overfilling a cable tray can restrict airflow, leading to overheating and potential damage to the cables. It can also make it difficult to properly train and support the cables. Fourthly, use appropriate cable ties or straps to bundle the cables together. The bundling method should not damage the cable insulation or create excessive pressure points. Avoid using metal ties that could chafe or cut into the cables. Fifthly, when routing cables through the cable tray, maintain adequate separation between power cables and signal cables. This separation helps to minimize electromagnetic interference. If power cables and signal cables must be run in the same cable tray, use a divider to physically separate them. Sixthly, inspect the cables regularly for any signs of damage, such as cuts, abrasions, or kinks. Damaged cable should be repaired or replaced immediately to prevent electrical hazards or signal degradation. Seventhly, ensure that all cable terminations are properly made and that connectors are securely fastened. Loose or improperly terminated connections can cause signal loss, intermittent failures, or even electrical fires. Eighthly, label all cables clearly and accurately. Proper labeling makes it easier to identify and troubleshoot cables in the future. Use durable labels that will not fade or peel over time. Ninthly, document the cable installation, including the cable types, routing paths, and support locations. This documentation can be invaluable for future maintenance or modifications to the cable system. Tenthly, comply with all applicable local and national electrical codes. The NEC provides minimum safety standards for electrical installations, but local codes may have additional requirements. In addition to the NEC requirements, there are other industry standards and best practices that can enhance the reliability and performance of signal tray cable systems. Firstly, consider using shielded cables in environments with high levels of electromagnetic interference. Shielded cables help to protect the signal from external noise. Secondly, use surge protection devices to protect sensitive electronic equipment from voltage spikes. Surge protection devices can be installed at the point of entry of the cables into the building or at individual equipment locations. Thirdly, implement a regular maintenance program to inspect and test the cable system. This program should include visual inspections, cable testing, and connect cleaning. Fourthly, provide adequate ventilation for the cable tray system to prevent overheating. Overheating can degrade cable insulation and reduce cable lifespan. Fifthly, use cable management software to track cable locations, connections, and maintenance history. Cable management software can help to improve the efficiency and accuracy of cable system management. The bending radius of cables is a critical factor in maintaining signal integrity and cable longevity. Bending cables too sharply can cause stress on the conductors and insulation, leading to performance degradation and potential failure. Cable manufacturers specify a minimum bending radius for each cable type, which should be strictly adhered to during installation. The minimum bending radius is typically expressed as a multiple of the cable's diameter. For example, a cable with a minimum bending radius of 6 times its diameter should not be bent in a radius smaller than 6 times the cable's overall diameter. When routing cables around corners or obstacles, use gradual bends to avoid exceeding the minimum bending radius. Use cable trays with rounded corners or cable guides to help maintain the proper bending radius. Avoid kinking or twisting cables, as this can also damage the conductors and insulation. In situations where space is limited, consider using flexible cables with a smaller minimum bending radius. These cables are designed to withstand tighter bends without compromising performance. When pulling cables through cable trays or conduits, use cable lubricant to reduce friction and prevent damage to the cable insulation. The lubricant should be compatible with the cable insulation material and should not degrade its properties. Avoid pulling cables with excessive force, as this can stretch or damage the conductors. Use a cable pulling grip or a cable pulling eye to distribute the pulling force evenly. After the cables have been installed, inspect them for any signs of damage, such as cuts, abrasions, or kinks. Damaged cables should be repaired or replaced immediately. Cable terminations are another critical aspect of signal tray cable installations. Properly terminated cables ensure a reliable connection and minimize signal loss. Use the correct type of connector for the cable and application. Ensure that the connector is compatible with the cable's conductor size and insulation material. Follow the manufacturer's instructions for terminating the cable. Use the correct tools and techniques to ensure a secure and reliable connection. Avoid over-tightening connectors, as this can damage the cable or the connector. After the cable has been terminated, test the connection to ensure that it is properly made. Use a cable tester to verify the continuity, polarity, and signal strength of the connection. Label each cable termination clearly and accurately. This will make it easier to identify and troubleshoot cables in the future. Protect cable terminations from environmental factors such as moisture, dust, and corrosion. Use weatherproof connectors or enclosures in harsh environments. Regularly inspect cable terminations for any signs of corrosion or damage. Clean or replace damaged terminations as needed. Grounding is an essential safety measure for signal tray cable systems. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Ground the cable tray system to a suitable grounding electrode. Use a grounding conductor of the correct size and material. Connect the grounding conductor to the cable tray system at multiple points. Ensure that all cable shields are properly grounded. This will help to minimize electromagnetic interference. Regularly inspect the grounding system to ensure that it is intact and functioning properly. Test the grounding system with a ground resistance tester to verify its effectiveness. In addition to the NEC requirements and industry best practices, there are several other factors to consider when installing signal tray cable systems. Firstly, consider the environmental conditions in which the cables will be installed. Cables installed in harsh environments, such as those with high temperatures, humidity, or corrosive chemicals, may require special protection. Secondly, consider the potential for mechanical damage to the cables. Cables that are exposed to physical hazards, such as impact or abrasion, may require additional protection. Thirdly, consider the potential for electromagnetic interference. Cables that are installed near sources of electromagnetic interference, such as power lines or radio transmitters, may require shielding. Fourthly, consider the future needs of the cable system. Design the cable system to be flexible and scalable to accommodate future growth and changes. Fifthly, consider the cost of the cable system. Balance the cost of the cable system with its performance and reliability requirements. By carefully considering all of these factors, you can ensure that your signal tray cable system is safe, reliable, and performs to its full potential. Remember that proper cable management and support are crucial for the long-term performance and reliability of any cable system. Take the time to plan and execute the cable installation carefully, and you will be rewarded with a system that is easy to maintain and troubleshoot. In summary, the NEC requires that bundled signal or data cables be supported at intervals not exceeding 6 feet. The cable should be trained to minimize bending radius and secured properly. Always consult the manufacturer's specifications for the specific cable being installed and comply with all applicable local and national electrical codes. By following these guidelines, you can ensure a safe and reliable signal tray cable installation.